All right, so I am recording this, but feel free to stop me at any time. I could always pause it and go back and re-record. We're still on simplifying square roots, right? And what we need to know is this fact right here, that the square root of something times something, that square root could be split to each of them. So the square root of something times something, it could be split to the square root of the first one times the square root of the second one, okay? And this comes very much in handy when we're simplifying square roots. What we first need to know or remember is how to produce a perfect square number list. Okay, so you should be able to create this list: 1, 4, 9, 16, 25. And how could you produce this list? By simply squaring each number. Now, what is square? It means the power of 2. So 1 to the power of 2 is 1. 2 squared is 4. 3 times 3 is 9. 4 squared is 16. 5 times 5, 6 times 6, 7 times 7. So if you go through that, you should be able to make this list on your paper whenever you're simplifying roots. Okay. Now, why do we want this list on our paper? Because here's a fact: the square root of a perfect square number is a perfect answer. We know that the square root of any one of these is a nice, beautiful, natural number, right? The square root of 9 is 3. The square root of 49 is 7. The square root of 4 is 2. The square root of 100 is 10. Now, it gets a little tricky when you have the square root of a non-perfect square number, right? So the idea is that when you don't have a perfect square number and you want to take the square root of a perfect square number, you rewrite it with multiplication to get a perfect square number. So most of us are going to see this 72 and think, well, 72 is not on this list, right? It should be somewhere here, but it's not. So I want to rewrite it with multiplication to get a perfect square number. Now, 4 times something will probably give us 72. 9 times 8 for sure gives us 72, but that's not our best option. The reason why I would recommend you to write this list is because you could look at the list and be like, okay, 9 times 8 works, but how about 16 times something? Or how about 25 times something? Or 36. 36 times 2 is actually 72. So the best option is to go with the highest perfect square number possible when you rewrite it with multiplication. You see, if you went with your first thought, right? 9 times 8. Imagine that, 9 times 8. So if you went 9 times 8, and then you split the square root of 9 and the square root of 8 being multiplied together. And then, of course, the square root of 9 is 3. And the square root of 8, it's not a perfect square number, but you could break it down with multiplication again to get a perfect square number, right? 4 times 2 is 8. So you could rewrite that as 4 times 2 and split the root again. And then, of course, you have the nice number 3 in the front, and you have the square root of 4, which is the nice number 2. And then the square root of 2 over here, you can't do it, so you just bring it down. And what you really have as a final answer is 3 times 2, which is 6, and the square root of 2 comes down. So that's not the best way to do it, right? Yeah, you want to rewrite it with multiplication to get a perfect square number, but don't go with the first perfect square number that pops up in your head. If you have your list, just take a couple more seconds and look at these numbers and recognize that there's a bigger one that could be used. 36 times 2 is 72. So check out the advantage of using the higher one. 36 times 2, split the root. The square root of 36 is 6. And the square root of 2 stays the square root of 2. Same exact answer. It's just done a lot faster. So I always recommend that when you're rewriting your number to get a perfect square number with multiplication, don't go for the first one, go for the highest one, right? Now, sometimes it will be the highest one, like this next one. What times what is 27? Anybody? 9 times 3, right? So 9's a perfect square number, and there is no higher number, right? Like 16 times something give you 27? No. 25? No, for sure. It's too big. So 9 is the highest perfect square number. So that one, yeah, the first number that popped up in your head, 9 times 3, that's the correct combo. Split it. The square root of 9 is 3, and the square root of 3 stays the square root of 3. All right. I hope we understand that, yeah? Let's take a look at this next slide. You see, you may have a number out in front of your root. Just simplify the radical and then deal with multiplying that outside value. So here's our first example, 4 square root of 12, okay? This is just the number 4 times the square root of 12. It's like if you had a 4x, what does that mean? 4 times x, but right here it's 4 times the square root of 12. So simplify the radical. How could I rewrite 12 to get a perfect square number? Okay, and you know what? Let me do this. Let me write down my perfect square numbers up here. And again, you want to rewrite this to get one of these perfect square numbers. So 2 times 6 would not be good because 2 is not a perfect square, 6 is not a perfect square. But yeah, 4 times 3 is a better combo, well, the best combo. 4 times 3, because when you split the root there, now you could actually do the square root of 4. The square root of 4 is 2. It's the nice number 2, no more square root. What about that square root of 3 over here? It just comes down at the very end. So we have simplified the square root of 12, but what about that 4 that's in front? That's really saying 4 times. So I need to bring down that 4 times. And we could now multiply the number 4 with the number 2. And what about that square root of 3? Just leave it there. So 4 times 2 is 8. So your final answer is 8 square root of 3. So 4 square root of 12 simplifies down to 8 square root of 3. Okay, so I hope you guys copied this example down and you understand now that whenever you have a number in the front, that's like, I mean, what does it say? It says 4 times the square root of 12. So do the square root of 12 first, simplify it, and you may have a number, a nice number out here that you could multiply with that first number that you had. Multiply those numbers and leave the root at the very end. Okay? So looking at example 1 right here, 5 square root of 8. Square root of 8. 8's not a perfect square number. I could rewrite that as what? Anybody? 4 times 2. So the 8 is going to become 4 times 2. We're going to split the root, bring down the 5. So what do we really have? We have 5 times, what is the square root of 4? 2. It's the nice, beautiful number 2. And what about the square root of 2 that just comes down? So it just stays, right? And now we have 5 times 2. We have these nice numbers. 5 times 2, that's 10. And the square root of 2 comes down again. And there's your simplified radical form answer, 10 square root of 2. If you're thinking, what does it mean, radical form? Radical form means that it's not a decimal. You have an actual square root, right? It's in the form of a radical. You could get a decimal answer for this on a calculator, but it is irrational. It's a crazy long decimal with no pattern or repetition. Anyway, moving on to number 2. Once again, you have a number out in the front. You have a number in here. If you could simplify it, which we can. We want to rewrite it with multiplication to get a perfect square number. What would I rewrite it as? Should I rewrite this as 6 times 3? No, why not? Because there's no 6 up here, there's no 3 up here. What should I rewrite that as? Exactly, 9 times 2. Thank you so much. 9 times 2. We're going to split the root, bring down the negative 3. Let's bring it down again. Negative 3 times the square root of 9, that's just 3. So you have negative 3 times a positive 3, and we bring down the square root of 2. So what is negative 3 times positive 3? That is a negative 9. Bring down the square root of 2. There's your answer, negative 9 square root of 2. Number 3, it's so easy that you might get confused, right? We have negative 4 times the square root of 25. What is the square root of 25? 5, right? Like that's just the nice, beautiful number 5, no more square root. What about the negative 4 that's being multiplied in the front? We're just going to simply bring that down. Negative 4 that's being multiplied out in the front. And of course, your final answer will be negative 20. Nice integer, negative 20. No more radical, no more square root. Any questions so far? So whenever you do have a number out in the front, that just means that number times whatever you get as an answer. And sometimes when you get that answer, you have an actual number out there that you could actually multiply them by. Sometimes you won't. But in this case, in these problems, we were. Let's move on. Okay, so we need to be comfortable with this rule that the square root of a times b is really the square root of a times the square root of b. And you can use this rule backwards. Janelle? We could use this rule backwards. Now, why the heck would we want to use this rule backwards? Sometimes it is a great advantage to use it backwards. For example, here, square root of 2 times square root of 8. I could actually multiply those together and write it as the square root of 2 times 8, and that would be the square root of 16, and the square root of 16 is 4. Pretty cool, right? So sometimes it's very advantageous to use this rule backwards, where you have two separate square roots. You could multiply them together and put them in one square root, okay? Even when you don't end up with a nice, perfect square number like this one, like right here, the square root of 3, could you do it? No, you can't. The square root of 6, could you do it? No, you can't. So at the very least, we could multiply them together. That way it looks a little nicer. That would be the square root of 18, right? And now you could ask yourself, well, the square root of 18 is not a perfect square number, but could I rewrite it with multiplication now to get a perfect square number? And the answer is yes. You could rewrite that as what? Exactly, 9 times 2, and you could split the root, and the square root of 9 is 3, and the square root of 2 stays the square root of 2. So 3 square root of 2 is your answer. Got it? Let's try another. We have the square root of 2 times the square root of 6. What would that be? Anybody? The square root of 12. Okay? And could you rewrite 12 to get a perfect square number with multiplication? Yes, right? That would be 4 times 3. So when you split that root, you'll be able to do the square root of 4, which is the nice, beautiful answer 2, and the square root of 3 stays. How about this last one? Square root of 4 times square root of 4. It's so easy you might get confused. What's the square root of 4 times square root of 4?
16.
The square root of 16, right? And what's the square root of 16?
32.
4. Because 4 times itself gives you 16. Now, the beauty of math is that there's so many different roads to the same place, right? So, for example, but do you guys understand, before I even show different roads? Like right here, oh, sorry. Dang, I just messed that up. I accidentally erased that. Okay, so right here, the square root of 2 times square root of 8. You guys understand that we put these together, and then we were able to get the answer, right? Now, what if we didn't do that? You could have also simplified the square root of 8. So here's an alternative route. The square root of 8 could have been rewritten as 4 times 2, and then you could split the root. And then the square root of 4 is 2, and the square root of 2 stays. But you still need to multiply it by this first square root of 2. So times the first square root of 2. And you could actually multiply the radicals together. So you could rearrange this, put the 2 in the front, and then you have the square root of 2 times the square root of 2, which would be 2 square root of 4, which would be 2 times 2, which is the same answer 4. Why the heck would you want to do that? I don't know, if you're bored, right? Super easy. The first way we did it, they were separate, put them together, do the square root. Okay. Let's try a different concept here. The reality is you can multiply square roots with square roots and multiply numbers with numbers. So everybody jot this one down. 2 square root of 2 times 3 square root of 6. You could multiply the numbers with the numbers and the radicals with the radicals, the square roots with the square roots. So what do I have here? I really have, showing my work, 2 times 3 times the square root of 2 times the square root of 6. So 2 times 3 is 6, and the square root of 2 times square root of 6, that's the square root of 12. And then you could simplify 12. You want a perfect square number in there, that's going to be 4 times 3, and then split the root. Don't forget to bring down the 6. And the square root of 4, this guy right here, square root of 4 is 2. So what you really have is 6 times the square root of 4 is 2. And then the square root of 3 comes down, leaving your final answer 12 square root of 3. Let's take a look at this next one. Once again, you could multiply the numbers with the numbers. We already know 4 times 3 is going to be 12, and 2 times 10 is 20. So you could rewrite it as 12 square root of 20. Or you could show your work in detail the way I did over here. Actually rewrite it. 4 times 3 times the square root of 2 times the square root of 10. That becomes 12 square root of 20. Now, I guess doing this step is kind of pointless, but I'm showing it to you right now because you really could just rearrange it. 4 times 3, 2 times 10, 12 square root of 20. So now try to simplify the square root of 20, and at the very end, if you have a number on the outside, you could multiply it with the 12, outside of the root, that is. So 20 is not a perfect square number. I want to rewrite it with multiplication to get a perfect square number. Would 2 times 10 work? No. Why not? Because 2 is not a perfect square, and 10 is not a perfect square. Again, the whole purpose is to get a perfect square number so you could actually do the square root of it, right? So what would the correct combo be? It would be 4, because 4 is a perfect square number, times 5. That way you could split the root, and the square root of 4 is 2, and the square root of 5 will stay the square root of 5. So we have simplified the square root of 20. What about the 12 that's being multiplied out here in the front? Bring that down. So you have a times 12 out here in the front. Bring it down, times 12. So your final answer will be 12 times 2, that's 24, and you bring down the square root of 5. And finally, to the last concept of the lesson today, imaginary numbers. Ladies and gentlemen, write this down. Imaginary numbers, and this is the one important rule right here. The square root of -1 is I. It's imaginary. Okay, let's begin with something that we're familiar with. What is the square root of 9? The answer is 3. You just said 3. Why is the answer 3 to the square root of 9? Why? Because 3 times itself, 3 gives you the answer 9, right? When I say what's the square root, I'm really asking what number times itself gives you this answer, right? So the square root of 9 is 3 because 3 times itself gives you 9. So what do you think the square root of -9 is? A lot of people say -3, but that's not right, because -3 times itself, -3 times -3 is +9, not -9. So when I say what's the square root of -9, I'm asking you what number times itself gives you this -9. It's impossible. There is no such thing. There is no such real answer that you could multiply with itself that'll give you a -9. So the actual answer is an imaginary answer. The answer is 3i. 3i. That's the answer to the square root of -9. Okay. Now, the actual work that if you wanted to show somebody, demonstrate your knowledge on this, you would say that the square root of -1 is I. So what you could do is rewrite -9 as -1 times +9. So -9 is really -1 times +9. And then you could split that root, split the root, and of course the square root of -1, that's going to be I, and the square root of 9, that's going to be 3. So you really have I times 3, that's like x times 3, that would be 3x. You put the number first and the variable next. So that's how we get the answer 3i. Now this work looks and sounds complicated, but you don't have to show all this work. The reality is this: whenever you have a minus sign in here, you could move it out and it'll become an I, a variable I on the outside, and then that'll become positive. So it's this simple. This -49, the square root of -49, that negative sign could be moved out here to the front, and it'll become I times the square root of +49. You don't have a negative anymore. You move that I out. You move that negative out, and it became I. And now the square root of 49 is what? 7. So what you really have is I times 7. So your answer is going to be what? 7i. In Algebra 2, we work with imaginary numbers a lot. We actually add them, subtract them, multiply them. But in Algebra 1 right here, we need to understand this truth that whenever you have a negative in there, it comes out and it becomes I, and then you could treat it like if it were positive. So what's the answer to this guy without even showing any work? The square root of -16. 4i. Now, a lot of students get confused with this one. They think it's 5i, but no, that's not 5i. What's the answer to this guy?
Is it I? I wait, no, 5.1.
High five? No. Okay, think about this. Think about this. There's a negative out here in the front. It's not the square root of a negative. What is the square root of the 25? What's the square root of 25?
It's 5.
Yeah, it's 5. So what about that negative sign in the front? You just bring it down, right? So the square root of 25 is 5. And what about the negative in the front? Just bring it down. Your answer is negative 5. So be careful with that. The only time you get imaginary numbers or the letter I is when you have a negative on the inside, okay? So right here, there is no negative on the inside. The negative's on the outside. What do? You do the square root of 25, you get 5, and put the negative in front. Negative 5 is your answer. How about this one? Here's another mistake that a lot of students make. They see this negative and that negative, and they want to change them to plus plus because they're so used to seeing a minus negative changing to plus plus. But the reality is you have to deal with the square root first. So what is the square root of negative 36? What's the square root of negative 36? 6i. 6i. And what about the negative that's out in the front? You just bring it down. So your answer is negative 6i. Cool. How about the square root of negative 12? Again, whenever you have a negative sign in the front, you can just move it out, make an I out here, or put an I out here, and make that positive. So, you know what? Let's go to a blank page so we can have more space. Here we go. The square root of negative 12. I'm going to begin by taking the negative, moving it out here, and making it an I. So I'm going to have an I on the outside, and now I don't have a negative in there anymore. It's now just a regular square root of 12. And we all know how to simplify the square root of 12. That's going to break down to 4 times 3, not 2 times 6. 4 is a perfect square number. That's what you want. So 4 times 3, split the root. Don't forget about the variable I. And of course, the square root of 4 is 2. So you're going to have a 2 right here. No more square root. But you do have the square root of 3, and you do have I. So what you really have is the variable I times 2 times the square root of 3. And the correct order to write your answer would be the number first, the variable next, and the radical, the square root at the very end. So 2i square root of 3 is the final answer to that one. Okay? Once again, if you have a minus negative, don't change it to plus plus. Wrong. Don't do that. You got to deal with the square root first. And then you could slap on a negative on your answer at the very end. So let's deal with the square root first. What's the square root of negative 20? Well, first of all, the negative sign, you could move it out and make it a positive I. And now you'll just have a positive 20 on the inside of the square root. Okay? Positive 20. I need this to be a perfect square number. What should I rewrite it as? 2 times 10? 4 times 5, right? 2 is not a perfect square. 10 is not a perfect square. But 4 is. So yeah, 4 times 5. That way you could split the root. What is the square root of 4? 2. Nice, beautiful number 2. What about the square root of 5? Bring it down. And what about the I that's out here in the front? You need to bring it down and multiply it by 2. So you have an I times 2 times square root of 5. How are you going to write it correctly? 2I square root of 5. Or the correct order. Okay? Now, what if I had... oh, you know what? I messed up on this one. This is what I wanted here. I wanted to put the square root of negative 15. Okay? Square root of negative 15. So I apologize for that mistake. But let's say I had the square root of negative 15. Well, what about this negative sign? What do I do with it? I remove that negative sign and make it an I on the outside. So put an I out here, and then you'll have the square root of 15 on the inside. No more negative. Now, could you rewrite 15 with multiplication to get a perfect square number? You could break it down to 5 times 3, but is 5 a perfect square number? No. Is 3 a perfect square number? No. So it's pointless to break it down. You can't break it down multiplication to get 4 times something to give you 15, or 9 times something to give you 15. In other words, the square root of 15 is as simple as it gets. So this is your final answer right there. I square root of 15. Okie doke, guys. I think this lesson's been long enough. We have 2 assignments on Google Classroom, on the quizzes platform, 100 points each, based off of what we just went over today in class.